Okay, how many unique words can you create by rearranging the letters in the word Canada? We can understand immediately that all we're doing is rearranging these 1, 2, 3, 4, 5, 6 letters. And hopefully what's immediately obvious to you is that this is a trickier situation because we have 3 letters that are identical. So we don't have distinct items that we're arranging here. So we still start off the same way. I guess you can think of your fundamental counting principle. If we're going to arrange all 6 letters, 1, 2, 3, 4, 5, 6. Be nice to jump right to our factorial notation, but maybe we'll do this one last time. This is going to be all 6 letters, followed by 5, 4, 3, 2, 1. Of course, this is the total number of arrangements of those 6 letters, which you can check with your calc, which you would be inputting 6 factorial, and that is 720. Now, of course, that's not going to give us unique words, or I guess what I should be calling unique arrangements here because of those identical A's. So let's just take one such arrangement. One of those 720 arrangements would be spelling Canada backwards. So we'll go AD, ADA, NAC. If you've ever spelled Canada backwards, there we go. Now I'm going to put subscripts on these A's just so we can start to see that there's, you know what, we can get a whole lot of duplicate words simply by cycling through these A's. Of course, they cycle through various positions there. So how many ways can we arrange all of those 3 A's? Now hopefully you say to yourself, well, I start off with all 3. If I use 1, I'm left with 2, followed by 1A. So there's going to be 3 factorial, or 6 ways that we can arrange those 3 A's just in this one configuration where we actually get Canada spelled backwards. So for of these 720, hopefully this is telling you that you should be dividing this 720 by 6 to get rid of all this duplication. And let's just illustrate further. We're going to make sure you understand what I'm talking about by cycling through those A's. I'm in the correct color here. Well, we already have this one, A1, 2, and 3. What if we have A1, and then I have I swap A2 and A3? If assuming that, I guess pretending, not assuming, but pretending that they're actually distinct, which of course they aren't. And hopefully you recognize that this is the same word. This is still Canada being spelled backwards. So I got 2 of our 6 possible ways we can have Canada spelled backwards. Now, of course, I have to put a different A in the front, so let's put A subscript 2, and then we'll put 1 and 3 in these other 2 slots. And hopefully you're also noticing that if really all I need to focus on here are the 3 A's, because I'm just kind of mindlessly writing down D and C every single word. So there's our 3rd one, and if I just swap A1 and A3 in those 2 positions, we now have our 4, and we'll finish it off with 2 more. If I start with A subscript 3, and I'm going to have to go A1 and A2. See, and then finally the easy one, now I just have to go A3 again and swap these 2, A2 and A1. So hopefully you see all of this as a whole lot of redundant writing. There's 6 unique ways if A, 1, 2, and 3 are distinct, but of course once we remove our subscripts they're not distinct. So of these 720 we have to divide that by 3 factorial, which of course is 6, and you can check this on your calculator. That'll give us 120 unique words. So let's clear all this off. Hopefully I convinced you that that makes sense, that we're getting a duplication now, not twice as many duplicate words, but a factor of 6 this time, which of course is not a coincidence that there's 3 factorial or 6 ways that we can arrange those duplicate A's. So really all I needed to show here, we say 6 factorial, which of course the total number of ways of arranging all 6 of those items, and then dividing that by 3 factorial. That would give us 720 over 6, which of course is 120 unique words or rearrangements of these 6 letters. Okay, so let's follow up our written work using the permutation generator again, and I have the letters in the word Canada already entered as a custom list, and let's generate all those permutations, which of course includes duplication. As we can see, Canada is in row 1 and it's also there, and it will be 6 places in total in this extensive list, which should be 6 factorial or 720 rows long, and of course it is 720 different permutations. If we get rid of our duplication right there, so keep only distinct permutations, which remember just means get rid of duplications, we'll generate permutations again, and we'll see that that gets chopped down to 120. And you can look through that list on your own. You won't find any duplicates there now that we've divided by 3 factorial.